Welcome to math class. Today we are looking at set theory. Okay, and before going into that, please remember, whenever you get this video, press the thumbs up, okay, just to subscribe to the channel. The subscription button, just press it, and after studying or doing what is on the video, you can easily share it to your friends also. Okay, just share the link to them so that they can watch also and do the work. Okay, so today we are looking at set theory. This is not the first time we are considering this. We've done a video on this before, and the previous one we look at the definition of sets, okay, and we look at the basic terminologies in sets, your union, your element, your subsets. We'll look at the types of sets also, disjointed sets, and so on. So today we are looking at Venn diagram. Venn diagram. I will say that Venn diagram is a geometric interpretation of sets using diagram which show different relationships between sets. The Venn diagram is all about the interpretation, the geometric interpretation of sets using diagram. Now, we are going to consider two relationships. Relationship between two sets and relationship between three sets. That's what we'll be looking at today. Relationship between 2 and 3 sets. So here, relationship between two sets. The first Venn diagram here says that P is a subset of P, of the element here. P is a subset here. And the second one here says that P is a complement of the set here. Whenever, in the previous one, I told you that whenever you see an element having raised to power 1, it simply means a complement. And see here, we have an intersection. P intercepts Q here. This is an intersection, okay? And there's another diagram. This one shows that the element in P, not in Q. The element here, this side that is shaded, is not in Q. So when you have to interpret this, it is P difference Q or P intercepts Q complement. Okay, P intercept Q complement. Okay, so we'll look at another one. This is another Venn diagram. This is here. You can see that everything here is shaded. That means P union Q, P union Q. The next one, this is separated. That means P and Q are disjointed. They are disjointed. And you can write it like this. P intercept Q is null, or it is empty. That means there's no intercept between the two of them. Okay, then the last thing we'll be considering under the relationship between two sets is P. This is a Venn diagram. I will say that P is a subset of Q. P is a subset of Q, and that can be written with a symbol. Okay, then we have the last one here. The last one here. This is a Venn diagram, and you can see representations on it. Now, this is element of A, and this are elements of B, and it says that A union B complement, or the complement of A intercepts the complement of B. Okay, complement of A intercepts the complement of B. So now we look at relationship between three sets. Relationship between three sets. The first one says that P intercept Q intercept R. That is when the middle of all these three sets is being shaded. Okay, when you have elements here, that means the intercept of P intercepts Q intercept R. Then the next Venn diagram here says that Q intercept R intercept element complement of P. That means it is only here that is being shaded. If only here is being shaded also, it will be P intercept Q complement of Q. And if only here is shaded, it will be P intercept Q complement of R. Okay. Then now we have only Q, only P shaded here. That means it is P intercept complement of Q intercept complement of R. That means it is only Q that is being shaded. And if it is only Q you are being asked to look for here, it will be Q or P intersects Q, P complement intersects Q, intersect complement R, or if you like you can rearrange it and let Q come first. If you have to look for Q, it will be Q intercept complement of P intercept complement of R. Okay, and here the O element is being occupied, so we have P union Q union R. Okay, and here they are being separated. That means PQR is disjointed. The Venn diagram here shows that the three elements are disjointed, and this is the final one. Okay, this represents everything here. You can easily interpret everything. Everything has been denoted to you. So this is a bigger picture of the whole thing you have. So having gone through everything that has to do with Venn diagram, I'll give you some exercises to do. See you in the next class. Okay, let's consider some examples and exercise before we call it a day. Examples. Number 1, in a class containing 32 students, a student can either do government, history, or both. If 16 students do government, 18 do history, and 3 do none of the subjects, find out how many do both. So let's solve this now. Solution. Okay. Number 1, the first thing you do is to draw your, okay, let's write out the union. The total here is 32 students. Okay, and let's use G for government. Government here we are told is how many? If 16 students do government, 16 students, then history, H is 18. Okay, so this is our Venn diagram. Okay, our Venn diagram. Okay, remember we are asked neither of the three, neither the ones that do neither of the two subjects. Neither of the two subjects will be element of G union H complement, that is 3. Okay, so we have this. This is government, this is history, this is those ones that do neither of the two, and our union here is 32. Okay, then number of people that do government is 16. Remember, we are looking for those that do what? Find out how many people do both. So minus, let's assume this is Y, and this will be 13. 18 people do history. That's 18 minus Y also. Okay, so how do we solve this now? The first thing we'll do is to put everything together. Okay, that will be 16 minus Y, okay, plus 18 minus Y, okay, then plus this plus Y, okay, then plus this equals to 32. That is the total, that's the union of everything. Then let's collect our like terms now. Okay, let's put the numbers together. This plus this plus this. 18 plus 16 plus 18 will give us 34 plus 3, that's 37. Okay, Y minus Y will give us minus 2Y. Okay, minus 2Y plus Y will give us minus Y equals to 32. We'll collect our like terms here. Okay, this should be Y equals to 37 minus 32. So Y here will be equals to 5. So those that offer the both subject, find out how many people offer both. Those that offer the both subject is 5. Okay, so that is that for that. Let's look at 2 now. example 2 now. The question says out of 400 students, okay, out of 400 students in the final year in a secondary school, 300 are offering biology and 190 are offering chemistry. The first question is, how many students are offering both biology and chemistry if only 70 students are offering neither biology nor chemistry? So the union here is 400 students, okay. Then those offering chemistry, there are 300 students, okay. 300 are offering biology and 190, okay. Chemistry is 190 students, then biology is 300 students, and those offering none of the boards, that is element of C, union B, complement is 70, okay. Then we'll draw a Venn diagram now, okay. So those offering none, 70, are union 400, okay. Chemistry, that's 190 minus, let's tag this one X, then let's put this one X, that's the number offering the both, which is the question we are looking for, and this will be 300, that is biology, 300 minus X. So let's solve this now. The question is, how many students are offering both biology and chemistry? The first thing you should do is to look for the total of everything. That's 190 minus X plus 300 minus X plus 70 equals to 400. Okay, we'll collect your like times. This plus this will give us 490. 490 plus this will give us 560. X minus X plus minus X will give us minus 2X. Minus 2X plus X will give us minus X equals to 400. Okay? Then the next thing we'll do here is to collect your like terms. So this will be X, okay, equals 560 minus 400. If you like, if your X come here, to still be positive X, which is this, and once this one come here, it becomes negative. So that was the arrangement. Then if you minus it from each other, X will give us 160. That is A part of question number 2. So those offering both subjects are 160. Then the second question says, how many students are offering at least one of biology or chemistry? One of biology or chemistry. At least means they must do one. They can do more than one, but one of biology or chemistry must be part of the works they are doing. One must be there. So it can be more than one, it can be more than two. They can do maybe only biology, chemistry, or the both. So since there's no need repeating this again, or for better understanding, B, we have 190 minus X. There's no need repeating it since we know that our X is 160. Let's just put our 160 straight, plus this is 300 minus 160, then plus 160. Okay, those are the ones offering at least one. So this minus this will give us 30, plus this minus this will give us 140, then plus 160. If you add these three together, this is 300 and this is 330. So those ones offering at least one of the subject is 330 students. Okay, so that's all. So these are the exercises you're going to do. Number one, use a Venn diagram to illustrate the information below. You have this, and this. Then number two, in a class of 40 students, 25 speak Hausa, 16 speak Igbo, 21 speak Yoruba, and each of the students speak at least one language, one of the three languages. If 8 speak Hausa and Igbo, 11 speak Hausa and Yoruba, and 6 speak Igbo and Yoruba, the first question now is, draw a Venn diagram to illustrate the information using X to represent the number of students who speak all the three languages. All three languages. Then the second question is, calculate the value of X. Yeah, bye.